Welcome back, all. Today I will introduce you to the basic concepts of generic programming. Now, the term generic is basically defined is just a characteristic of some sort of a group or class of things. It is not specific, so basically the opposite of specific. Here we will go over generic functions. These functions have the same body but can accept anything as a parameter, as opposed to the functions which we have been using previously, where you have specific parameters that are whose types are defined, and the functions can only accept parameters of those types. Here we will basically create functions that can pretty much accept anything as a parameter, which is a very useful concept. And generic programming is basically based on deduction or type-based parameters. Based on the parameter type, compiler will decide which function to call. There are two types of deduction. You have partial and complete. In complete deduction, we know nothing about the parameters, so nothing is known about the parameters. Whereas in partial deduction, there is some additional information. For example, we know that the parameter is an array, but that's pretty much all we know about it. Anyway, let's go ahead and take a look at the generic functions and type deduction. So that's really what I wanted to go over with you in this set of tutorials, or a tutorial, depending on how much time will I require to actually finish this. So let's go ahead and create a void function. Let's call it print, and we shall have int arr. Okay, so nothing new here really, and int len, so int length, just a short version of it. Let's go ahead and prototype it and go down below and actually create the body of the function. Let me just Let me just go ahead and copy this. So as before, nothing new, nothing strange here. We're just going to go ahead and create the body of the function. So std, just going to go ahead and create a bit of a printout here. Yep. Okay, so there you go. And we're going to need a for loop, because this is going to be our beginning. You're going to have an opening of a bracket, and then we're going to have a for loop, which will print out all the elements, probably except for the last one, and we're going to have some sort of logic embedded there, and then at the end we're going to close it all with another block, like this one here. So here's what I am intending to do here. I'm just going to go ahead and say int I equals 0, and I is going to be less than length minus 1, and it's going to be plus I. We're not going to need any curly brackets down below, as we're just going to have one single line, and this will ensure that we basically manage to print out all the elements except for the last one. As you can see, it's length minus 1, or len, variable len minus 1, where len will be the size of the array. Since we go up to len minus 1, which means 1 lesser than the complete length of the array, we cannot access the we cannot basically access the last element, and this happens when an array is we cannot access the element which is len minus 1, so we can't access the minus first element, so to say. Actually, I'm doing a very stupid explanation of that. Let me just go ahead and show you, like, through the code. It's kind of difficult to put it in words, as it's a fairly strange thing, so to say. So let me just go ahead and write it out, and then I'll explain it while you're actually looking at the code. I do believe that it's going to make way more sense that way. Okay, and and L. Okay, so this is going to print out the closing bracket outside the for loop and outside of the if. So look, we have opening bracket, opening block. It prints out all the elements of the array. So it prints out one element, and there's a comma, space, comma, space, comma, space, and so on and so forth. It goes until until I becomes equal or greater than len minus 1. And then down below, you have len not equal to 0. So if the length is not equal to 0, if we haven't initialized an array whose size is 0, so if the length of the array is not equal to 0, then please create a printout after the for loop, which will go like this: arr len minus 1. So it will basically create the printout of this element here. Let me just put it like this. So it will create a printout of this element here of the array. Hopefully it makes more sense now with the if statement of what I was saying about a moment ago, and I was doing it in a really clumsy fashion. So this one here will not print out len minus 1 element of the array, but this one down below will print out element with this index. So element with this index will not be printed out in the for loop, but it will be printed out here. Okay, so now that we have that done, this is a regular function. Let's just run it. Well, we haven't actually called the function or initialized or passed the parameters or anything like that, but it doesn't matter. I just wanted to verify that the program actually compiles without any problems. Now in the main we can do the following. It shouldn't be that hard. We can have some sort of an array. I don't know, int arr, and okay, so I don't know, 2, 3, 4, minus 5, 1, 1, 0, ups, 0, 4. You don't need to type in the same values as I have. It's really not that important. And down below we're gonna have a const int len, because it does need to be a const. And look at what I'm about to do here. I'm about to type in size of arr divided by size of arr 0. So yeah, there we go. So size of is an operator which returns the size of an object in bytes. That is why we divide it by the size of an int. So yep, and down below we will type in print arr, comma len. So we're just passing the parameters now. Okay, no big deal. Oops, I seem to have made an error here. Equals, sorry. So we will initialize the size of len, so which will be the length of the array, with the result of these two here. So you have size of in terms of bytes of the first element of the array, and you have the size of the entirety of the array. So take a wild guess of what's going to get printed out onto the screen. Expected identifier before numeric constant. Well, of course, genius, it's a division. Okay, now you're confusing me. Seems to be the problem here. Expected a block before the comma token. Okay, there is a block here, and it is equal. Okay. Wrong. And let's go ahead and run it now. Okay, there we go. It says 2, 3, 4, minus 5, 1, 1, 0, 4. You see, they all got printed out without any sort of problems, and you even had a new line at the bottom. Now let's go ahead and discuss this part a little bit more. Let's go ahead and type in cout. I do believe that by just printing out the values of these these sizes of these bytes of the sizes in terms of bytes will basically just be self-explanatory. Cout size of ARR, and go ahead, size of ARR 0. Okay, that should be it. Maybe I should do this as well. Okay. Let's run it. So it's 32 and 4. What is 32 and 4? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. What is 8 times 4? 8 times 4 is 32. Why am I saying 8 times 4? Well, you have 4 here, and 4 is basically the size of the first element. What is the first element of the array? It's number 2. What is number 2? Number 2 is an integer. The size of an integer in terms of bytes is 4. So 4 bytes. So we basically said, okay, take the first element, give us the size in terms of bytes, which is 4, and then combine the bytes of all the elements, and then divide them by 4 to get the number of elements within the array. So let's go over that again. Integer has the size of 4 bytes in your RAM. So you have kilobytes, megabytes, gigabytes, etc. Well, integer is only 4 bytes in terms of size. Number 2 is an integer, which is the first element of the array. And we have stated, okay, go ahead and take the first element of the array, give us its size in terms of bytes. That would be 4. And then give us the size of all the elements combined in terms of bytes, which is 32. Okay, now divide it by 4 and give us the amount of elements. Give us the number of elements. Don't give us the size of the elements combined. Give us the number of elements within that the array contains, so that we would get the length of the array. Hopefully that is clear. So 4 is the size of a single element in terms of bytes. And once you combine all the sizes in terms of bytes and divide them by 4, you get the number of elements. Hopefully that explanation was actually useful. So this function that we have just created, the function print, is a regular, not a generic function which prints out an array of numbers, that is, integers. The problem is that the function only prints out an array of integers and nothing else. So if we had an array of, for example, real numbers, that is double. So if this was, for example, not int, but double, we would have problems. The function print will not print out these numbers. The solution to this problem is to write a function that has the same body, but also accepts an array of type double. So we could basically we could go about doing that, and in fact we will. So let me just go ahead and type int here. There's a considerable amount of prep work before we get into what we want to get into in this particular tutorial in terms of generic programming, because you do need to do some preps. So if we basically just do this, void, we will create a function overload here. Print, and this will be double ARR. Okay. It's going to be int len again. So this will be an overloaded. These two functions are considered to be overloaded. Why? They have the same name, they have the same declaration, but they take different parameters. Oops, am I that stupid, really? Okay, embarrassing moment there. Anyway, what we have done here is overloaded function, created an overloading function. So do you know what is the difference between these two functions? They have the same name, they have the same declaration, the same prototype, everything's the same except for the arguments that they take. So if you have two functions of the same name and they don't need to be void, they can also have a return type, but take different parameters, that means that you are overloading functions. So how would a program differentiate how would a machine differentiate if you call a function with print? They both have the same name. Well, it would differentiate in terms of the arguments passed. So if you passed a double array, an array of doubles, it will take this function into consideration. If you pass an array of integers, it will take this function into consideration. So let's go ahead and create the body for this function and see how that actually works in practice.